So the first thing that we are going to calculate is the mean squared between. And this is kind of like the difference between the means, but we needed to do it in variance. So mean squared between is the variance between the sample means. So it's kind of the squared version of what we did in the t-test. So it's the variance between the sample means. So if the sample means are all together, so in this first one we have a low mean squared between. So between the sample means. So here the dotted lines represent the sample means. So if they're all together and they're all around the same area, that means we have a low mean squared between. There's not a lot of variability between the means. But if there's, in the second example, if we have it where there's more spread out, then this is a high mean squared between. There's a lot of variability between the sample means. And so when we have a lot of variability between the sample means, that means that they're different from each other, right? And then that means that our ANOVA will be significant, and we can say that there is a difference between the sample means. So to calculate the mean squared between, first we need to know some information. And we're going to do an example with 3 groups. We have their sample sizes and their sample means. And we're going to do a sample with the same sample size for each group because it makes it a little bit easier. You can read the handout to see what you do when you don't have the same sample size. But I'm going to start with the same sample size because it's a little bit more intuitive to think about when we do it with the same sample size versus if, N1 was 15, N2 was 20, and N3 was 30 or something like that. So we need this information, and then so I'm going to show you how to calculate the mean squared between. So remember we had 3 groups, and the first group had a sample mean of 10, second group 20, and the third group 30. So the first thing is you want to find a grand mean, and when you have equal sample sizes, it's just the average of the 3 means. So it's just the grand mean. I'm going to put a G right here. It's just going to be 20. So if you add these all up and divide by 3, so 10 plus 20 plus 30, and divide by 3, you'll get 20. Okay? So that's just the average. When we don't have equal sample sizes, it's a little bit different. It's just you just have to add up each individual observation and then divide by the total instead of averaging out the means. You have to take each score and find its grand average. But for now, we'll just consider when we have equal sample sizes because it's just a little bit easier. So we have this grand mean, and then we're going to find the variance of the 3 means, and it's going to be almost just like kind of intuitively you would think you would do it. And there's just one little extra thing that we have to consider. Okay? So what we're going to do is we're going to, like when you have variance, remember we'll just have a column of our x bars instead of just x's. And so we're going to have 10, 20, and 30. And then we're going to have our deviations from the mean, but this time it's from the grand mean. So we're going to have 10 minus 20. And so it's going to be negative 10. And then we're going to have 20 minus 20. That's just going to be 0. Then we're going to have 30 minus 20. And that's going to be 10. And then remember, we always have this column of squares. Just remember back when we were finding variance just for individual scores, it's kind of similar, right? So we're going to have negative 10 squared, just 100. And then we're going to have 0 squared, 0. And then we're going to have 10 squared, which is 100. Now, we're not going to add this column up. There's a little bit of a difference here, and this is the reason we do this is so we can compare it to the mean squared within, and that's kind of the total sum of squares for the individual values. So we kind of have to consider the sample size for each mean as well. And so we need a column of the ends, and they're all 20 in this case. And we're going to have a column of n times the squares. So I'm just going to do 100 times 20, so that's 200, or I'm sorry, 2,000. And then 0 times 20 is 0, and then 100 times 20 is 2,000 again. And then we're going to add these up, and I'm going to call this the sum of squares between. That's going to be 4,000. Okay, so it's very similar to just getting the variance like you would for an individual score, but we just have to multiply it by the n because we're using sample means instead of just regular scores. Okay, so then we have the sum of squares between, which was 4,000. So let me just erase everything for a second. So if you need to go back, just rewind. So we have sum of squares between, which is 4,000. Now we need the ms between, which is the variance. So remember, variance is usually the sum of squares divided by its degrees of freedom. And so we're going to do the sum of squares, which is 4,000. And then we had, right, 3 groups that we based our variance on, right? We had 3 sample means. And then we're going to subtract off 1 because we had to estimate the grand mean. So if you go back to the earlier phases where I talk about degrees of freedom, remember every time we estimate a parameter or a mean, we have to subtract off 1. So this is why we're subtracting off 1. And this is kind of our n of our groups. So this is the number of groups. And then we need to subtract off 1. And this whole thing here, this is the degrees of freedom between. Okay? So we have 4,000 divided by 2, so that's 2,000. Okay? So that would be our variance between the groups, which is called our mean squared between.